video, and the quality of the video is going to be determined by your individual internet. So
it had nothing at all to do with us.
No, because we weren't driving it, or it was school internet. So if you didn't get a chance to see it in its pristine HD quality that like it should be viewed, it is on YouTube if you want to watch it at a later date. So
perhaps even more than once.
You could watch it as many times as you want it. You could save it for like Thanksgiving, for your whole family could watch it. It's kind of your choice. Maybe save it for your birthday. Anyway, so one of the cool things about 6th grade science is we have this new curriculum called CPUP. And one of the neat things about CPUP, on their website at least, is they have a lot of little kind of vignettes on scientists, like real live scientists. And we're lucky enough today to be joined by one here. And so my brother studied at UC Berkeley. What were you there for, about a decade?
I'm just glad that I'm a real live scientist as opposed to the dead type of scientist,
Yeah. Well, maybe
it's nice being a live scientist.
If you had, something happened to one of the glaciers, they might have named it after you.
Well, one of the papers that I have read the most in my history as studying glaciers was by someone named Battle. And he used to work in bergschrunds, which are really hazardous parts of the glacier. It's the crevasse against the wall. And later on, he actually fell through some thin ice on a superglacial channel, which means the water that actually flows across the top of the glacier, and he ended up drowning.
Oh.
So,
Was this his final battle?
That was his final battle. But go on.
Anyway, so when Johnny was in school doing his PhD, I was lucky enough to help him out twice on 2 different glaciers. One just east of Yosemite called the Coness Glacier. And then later on, a couple years later, I got to go up to, were we in Alberta or British Columbia? Technically?
We were in British Columbia.
British Columbia, just adjacent to Banff National Park in Jasper, where Miss Maddox is going to maybe travel next summer, right? Anyway, we spent 3 weeks together. We didn't camp exactly on the glacier, just next to it. And we did field work for about 3 weeks. And it was one of the highlights of my entire life. So anyway, Johnny is here to take questions on what it is to be a scientist, what it is to be a New Brighton graduate, whatever. Questions about the video.
This is all news to me.
Geology questions, and like anything you've ever wondered. He went to UCSC also, so he knows a lot about Santa Cruz geology and things like that. So don't be shy. This might be the only time this entire year we have a real live scientist with us. So does anybody want to... Sometimes it's a little hard to tease things out of the students, but let's go. Who's got a question? Not everybody speak at once. Take your time. Take your turn here.
Well, you want to get the wording right.
Okay, what wording?
Of the question.
Oh, they want to get the wording right.
Yeah, you gotta think about it.
I think Elliot has his hand up.
Elliot, thank you.
Yeah, so my question is on the hot springs. You said there was magma under. How come it's not burning hot?
The magma or the water? Because the magma...
The water.
Well, the water can be burning hot. It depends on the temperature of the ground. It depends on how far down the magma is. Because the water... Typically it's from both rain and snow. So that falls all over the landscape. And some percentage of it trickles into the ground and becomes groundwater. And then that warms up because the rock is hot too, because the magma is underneath. And then it works its way back to the surface, and if it has to travel a long way, then it can lose some of that heat and it won't be burning hot. But if it travels quickly over a short distance, then you definitely could get scalded. And it's also worth remembering that the temperature of those hot springs can change rapidly. So when we were there was a gentleman and his partner, and he apparently visited frequently, and he said that it was much hotter than normal. So he had to get kind of off to the side, but then at other times people show up and it's not even warm enough to be considered, pleasant. Plus, it's right on the edge of the lake. So you have the mixing of the cold lake water with the hot water coming from underground, And so depending upon exactly where you sit, you can have a whole wide range of temperatures.
Yeah, so I think when a hot springs, I don't have a ton of knowledge about it, but when a hot springs happens, it's a lot of things have to occur for it to be just right to enjoy. So like in Yellowstone, there's a lot of hot springs and things that are just steam, right? Like geysers.
Yeah, sure.
So they're so overheated that they're just steam or a geyser or what have you. So that's why hot springs are really rare, because it has to be like a pretty exact situation that you can actually go in. And when you're there, there's all these different pools that people made, and they have little channels. And then if it's too hot, they can bring in some lake water. If it's too cold, they'll cut off the channel. So it's a really cool spot. And I didn't go in, but our daughters went in, and the air temperature, the ambient temperature was probably like, I don't know what, 50 degrees, 55 degrees.
Yeah.
And they were in the water, which was cool. Great question, Elliot. I knew you'd have a good one.
A fun thing that can happen though that on this subject is that if magma is working its way towards the surface and may eventually become an actual eruption or not, but if it gets close enough to the surface, because it is so hot, if it encounters water under the ground, which we call groundwater, it can actually, we say, flash it to steam. So it more or less instantly goes from being water to steam, which is basically gaseous, like water vapor, and there's an expansion in the volume when that happens, and so it actually causes an explosion. And there you get a huge hole in the ground because this thing just goes boom as the water flashes to steam.
And you hope that doesn't happen while you're enjoying.
Yeah, you
the hot
don't want to
spring.
be in the hot springs when that happens.
Yeah, but that also might be an indication that an eruption might be imminent, so people might leave the area.
You could be, sure. Yeah.
All right, cool. Let's...
Andre with the question.
Andre!
And Lena after that.
Awesome, thank you.
So, what do you study?
Now? So, the question is, what do I study? Well, I never like to mislead students because then they lose trust in you. So at the moment, I'm not actually studying anything beyond how to be a stay-at-home dad, because the pandemic has caused us to pull our kids from daycare. So I had to stop doing any research, stop doing any science teaching at the University of Oregon. But before this all, back when Luke was describing, I was a glaciologist. So I studied how glaciers move because they both flow and slide. I looked into how they erode the landscape. So they pick up rock and they pick up sediment and move it other places. And the majority of that was done in British Columbia, as Mr. Webb mentioned. But during my time in grad school, and after I was lucky enough to also go to New Zealand and Patagonia and Alaska and the Coast Mountains of British Columbia, as well as the Canadian Rockies and Switzerland and Antarctica. So I was all about glaciers and the various things that they do on the landscape. Is that what you wanted to know?
Yeah.
So Andre, were you curious about the path you would take to become a scientist at all?
I don't know.
Okay, well, let's see what Alina had to say, and then maybe we'll get back to that.
What experience did you do? Did you do big ones or small ones?
Big glaciers?
Yes.
So, all of you, I believe, are Californians, and as you heard at the beginning, we are also Californians, although I don't live there now. And California, much to my regret, is, under the present climate, only has small glaciers. And yes, it's true that those small glaciers are actually getting smaller and smaller. But that's sort of where my affinities lie, meaning that's what I decided I liked, was little glaciers, because that's what we had in California. But we ended up going to British Columbia because there the restrictions on our scientific investigations were a little bit lighter and the access was better. But we studied a small glacier. That became my specialty, is how little glaciers do their thing and the cirques that they form. But I have helped on projects that were not my own research on much, much larger glaciers, both in Alaska and in that trip to Antarctica, where the glaciers are many tens of miles, 20 miles, 30 miles long.
As big as Santa Cruz.
Yeah, sure. So I guess I've had experience with both, but the little ones were my favorites.
Miss Maddox, do we have any other questions in the queue?
We do. Marissa has their hand up.
What was your major in college?
So when I first started at college, and I wanted to bring this is a good thing to bring up, I think, because when I went to college, I was undeclared when I began, which meant I didn't know what I wanted to do. But I did suspect that whatever I ended up doing would probably be mathematical in some way or another, and probably be science, but as you're about to find out, it wasn't entirely known. So I did take math classes early on, even when I was undeclared, and I did take physics, and I took chemistry, all when I wasn't sure what I was going to do. But then in my second year of college, I actually came really close. I'm glad I didn't, but I came really close to majoring in economics.
Ooh, I mean, you were at UCSC, right?
And I was at UCSC. But economics has a lot of math, although most economists misapply it. That's a whole nother topic. So it wasn't guaranteed that I was going to be a scientist, but it's kind of a funny story, I think. At least it's funny to me, because at the end of my first year, my counselor, who was going over different classes I could take, said, why don't you take an earth science class? You like the outdoors. And I actually, this is a true story, I actually laughed. I was like, are you kidding? I am not some long-haired earth lover running around in a field with a hammer. But then it turned out not much later that I actually was a short-haired earth lover running around in a field with a hammer. Because I took a geology class in my second year of college and really liked it, and found that I was reading the chapters of the textbook that weren't assigned. But then even after that, it just felt like, man, could I really end up an earth scientist? And that's when I considered economics. I also considered physics. But by the spring of the second year, I declared in earth science. A little side note is that most people don't actually call it geology anymore, because during the 20th century, most geologists primarily worked with the fossil fuel industry. They were known for trying to find oil and natural gas and things like that. And now most scientists that are not connected to the oil industry like to be called earth scientists or environmental scientists, things like that. So I still am happy to call myself a geologist, because the word literally means like someone who studies the earth or the study of the earth. But you might hear a lot of, so I majored in earth science is the long and short of it, as opposed to strictly something called geology, although they're essentially the same thing.
And I've never really heard that whole story. That was really cool. And Miss Maddox, you also majored in something similar at Berkeley, right?
Yeah, so I entered college as an astrophysics major, and then by my third year in college, I realized I did not like physics as much as I thought I did. And my counselor, same thing, talked to my counselor, and they're like, wow, I noticed all the classes that you take for fun are about the ocean. So I took ocean sciences for fun, and I would do different electives about ocean. So I ended up majoring in earth and planetary science with an emphasis on marine science.
Oh, cool. Yeah, and so I didn't major in EPS, but I did take, I think, probably 3 classes that Johnny was not currently the TA, but the same classes that he was a TA later. And I really enjoyed it. I should have maybe added a minor, but I ended up majoring in anthropology and a business minor. All right, we do only have about, 5 more minutes. But do we have any more questions? These questions have been awesome. Anyone in the queue? No? So
It's like Andre's hand is up again.
Oh, Andre.
What is it like studying glaciers?
So studying glaciers, like so many science-related projects in this world that we now live in, has just an almost uncountable number of approaches, number of techniques, number of things you can do. Because a lot of glaciologists, again, that's someone who studies glaciers, they actually go to the glacier, and like Mr. Webb was describing, you sleep in a tent, and you have no control over the weather. So one day it's clear and warm and great, and then the next 3 days it's snowing, and you can't really do much of anything, followed by hail, and then sun, and then rain, lightning, all these possibilities that you can't foresee coming, and it's not always a whole lot of fun. Mr. Webb, we could claim that he was doing something heroic on the glacier, but he was in fact trying to sled down some icy slope and crashed the sled, and the sled hit him in the head, and he had a really big gash, and we had to super glue it shut because we were in the middle of nowhere. So there are hazards involved, certainly, but then for those people who are not too excited about time intense, you can go to Antarctica and just fly out for the day in a helicopter, and then maybe sample some ice. People do that with chainsaws and cores, and then bring it back to the lab in McMurdo Station. And then there are scientists who study glaciers who basically never visit a glacier in their whole life because they use satellites primarily and their computers to look at how the glaciers are moving or growing or shrinking or changing their color. There are lakes that form on the surface of the big glaciers, like the ice sheet on Greenland. You can even measure how thick the glacier ice is with a satellite now, and they've discovered there are big lakes underneath glaciers too.
Cool.
So you really have every option in terms of being in a nice heated office and typing away, or crawling under an actual glacier in the middle of nowhere with no cell service, no internet.
Ooh, it was rough.
A lot of things to eat though, because you don't want to get stuck up there without food. So, and you have to have a lot of carbs. So we had endless numbers of chocolate bars,
Mashed potatoes,
and cookies, and I mean, you name it, all the good stuff. I don't think I could do it now.
When I came, I kind of refueled your food supply at the store.
Yeah.
And I bought like 20 boxes of Chewy Chips Ahoy. That was like the main thing they wanted. And I bought 20 hamburgers at McDonald's to bring. And we ate those over the few days.
Glaciologists also, they work at many different, we say scales, meaning from the tiny, they look at the composition of the air inside bubbles that are a millimeter across, all the way up to what an ice sheet the size of, I mean, how big is Greenland? It's bigger than Oregon.
Big.
Yeah, it's bigger. Is it as big as California?
It looks bigger on the map because of the spreading.
So to the scale like the size of states. What else?
Well, in our class, so we are getting up against the time, but the way this is connected to 6th grade science is that later on this year we're going to talk a lot about climate change, and I think your research kind of towards the end of it started switching a little bit to look at climate change, right? And how that was really affecting the glaciers.
We looked at some of that, yeah, sure.
Yeah.
Well, I started to study permafrost too.
Yeah, and so that's a really big issue, and we talked in my class a couple of days ago about groundwater and water stored in glaciers and ice sheets, and we're going to talk about how that's getting less and less and less as climate change is occurring and sea level rise and all that stuff. So
I think my final comment from my perspective
Beautiful.
On that subject, and that is that regardless of what a glaciologist does, and regardless of really what any scientist ends up specifically studying, there are some commonalities, but not everybody wants to hear it. And that is that everybody has to be good at writing, because you have to write up your results so that other people can know what you did. And there's a lot of artwork involved because you have to make figures and images that explain what you found. So your art classes matter. And then most scientists end up doing some math. So unfortunately for some, there is some math involved. And then you have to make budgets of how you're going to spend the money that you're given to do the work. So you have to be on top of sort of the business, math, economics side of things. There's a lot of, what would you call it? Sort of humanities related things, because you might decide you want to study a glacier in Chile, and now you might want to know Spanish, and you should know something about exchange rates, and you need to know where they drive on one side of the road versus the other, because you travel all over the place. So in the end, it requires all the various skills that you're learning from your different courses at New Brighton.
Yeah, I think the overall takeaway is that you would say that your most important scientific training was here at New Brighton, right?
Yeah, everything else was just a little bit of nudging this way and that way, but the core of it came at New Brighton.
And you had Mr. Van.
I did.
Who else
I had
did you
Mr. Richter.
Mr. Richter.
But I don't remember.
Sixth grade at the time was just taught by the humanities teacher, if I remember correctly. They switched off. So.
Okay.
Anyway, I think we're out of time. It is 10:25. Is that right, Miss Maddox? So hopefully you enjoyed this. I thought this was great. Maybe we could Zoom Mr. Webb in or FaceTime him in another time in the year if you enjoyed this. Or I can go out and find some other scientists in town, or maybe Miss Maddox, if your husband, he does some sciencey stuff, he could come to give a lecture. But I'm gonna.
We do have all those videos from the past.
Yeah, we have some great videos
show what scientists do.
I'm not sure which ones those are, but anyway, if you have any questions for me, Miss Maddox, or my brother, Dr. Johnny Webb, shoot me an email, and we'll have kind of regular class on Wednesday. And I guess you have break now. I'm not sure. Is your next class start at 10:40?
Yep.
Okay. All right. Well, I guess that'll be that. Thank you for being here.
Thank you. It was fun to be here.
All right, that was cool. Have a great rest of your day,
Bye,
students.
Miss Maddox. Bye, everybody else.
Bye, Mr. Webb. Bye, Miss Maddox.
Bye. When's our next class?
Bye, Mr. 10:40. Your next class is at 10:40.
That was great.